Our next topic in our tour of fancy pricing schemes is two-part tariffs. Two-part tariffs provide another way to capture some of the area under the demand curve as surplus for sellers. These differ, though, in two ways from things we've seen before. First, they're self-selecting. Now, rather than treating different consumers differently, these treat all consumers the same, but by presenting them with two prices, as we'll talk about, one for hooking up and one for each unit consumed, in effect, consumers get treated differently even though they face the same schedule. So we'll get into that more as we go. This second way in which they're different is that they literally have two parts. Instead of just a single price based on the number of units consumed, now there will be a membership fee, if you want to call it that, or a hookup fee of T, and that's what you pay just to have the right to purchase things. And then there's like a usage fee, which is a price per unit consumed. Of course, you can only pay that price per unit consumed if you've already paid the membership fee. And the question here is, can we generate more profit using these kinds of schemes than, say, just using a price, a single per unit price? Before we get into the analytics of this, it's worth pointing out that these are used in real life and they are very important for some firms. Here's a little discussion of Costco, the wholesale club. In 2010, they had net earnings around $1.3 billion. And if you kind of calculate out the role of membership fees in this, their membership fees are roughly $50 a year, and about 28 million folks were members. If you multiply that out, that's about $1 billion in revenue right there. Now, it's pretty clear that membership fees are an important aspect of this company's bottom line. We'll start with just one kind of consumer. So there could be many of them, but they're all the same, and that's what a consumer looks like. So what's going on here is that this is like units. Let's talk about it as though it were a golf club. This is rounds of golf played, let's say in a year. That's Q. And on the vertical axis is the price we're going to charge per round of golf. Now, we're going to have two things, though, two different prices. One is a per unit price, and the other is a membership fee. And the question is, how should we set those two, the P and the T, to maximize profit? Well, suppose we set a price equal to this P1. All right, now, I should have noted marginal cost is this line right here. So you can see marginal cost is there. Suppose we set this price at P1, which is above marginal cost. The question is then what happens? Well, first of all, and let's also suppose that so far, just for illustrative purposes, we don't have a hookup fee. So we've just set a price of P1. What does the consumer do? Well, we look at the intersection of the price and the demand curve. The consumer will consume Q1 units at a price of P1 per unit. And there will be some contribution to profit from these per unit sales. What is that contribution to profit? Well, it's region 1. Because they're paying P1, the marginal cost is MC, and so this vertical distance is the contribution to profit per unit, and they consume units all the way out to Q1. So the entire region 1 becomes a contribution to profit from per unit sales. The next question, though, is how high could we set the membership fee and still get the consumer to join? Well, one way to answer that question is to think, well, how big was the consumer surplus that the consumer obtained when they were paying that per unit fee of P1? The answer is that this entire region, region 2, was consumer surplus when they faced a price of P1. What if we were to charge them a membership fee equal to, or let's just say slightly less than, that region, region 2? Well, that's the highest we could charge and get them to join. So we could obtain region 1 plus region 2 as revenue if we set a price equal to P1 and a membership fee T equal to the full area of region 2. Now what about region 3 under this scheme with a price of P1 and a membership fee of region 2? Well, the answer is that's going to be deadweight loss, because since there's a per unit price of P1, there are these instances where the consumer would have been willing to pay this much and the marginal cost was just this much. Those transactions don't occur though because the per unit fee is P1 and the willingness to pay is below the per unit fee. So region 3 is deadweight loss. Well, a question we can ask is whether that price of P1 gave rise to a scheme that actually maximized our profit. To help us think about that, let's think about an alternative. Now this is just like the previous diagram, except that we've also added a new price called P2, which is between P1 and the marginal cost. Now we can ask the question, what is the contribution to profit from the per unit sales? And with a price of P2, the quantity consumed will be Q2, price per unit is P2, and so the contribution to profit from the per unit sales is the entirety of D and E, so those two rectangles. At this point, with a price of P2, how high can I set the membership fee and still get consumers to join? Well, I can set it at A, which is what it was in the last slide, but now plus B plus C. If we think about that then, summing up, when we had a price equal to P1 and a membership fee as big as we could make it, the maximum profit was A plus B plus D. This, and this. But with a price equal to P2, the maximum profit now is higher. It's A plus B plus C plus D plus E. So you can see that we did something better here. We were able to get more of this area as profit. Now, is this the best we can do? Well, you get a hint from the fact that there's still some deadweight loss here. This region F is still not available to either the buyers as consumer surplus or to the sellers as producer surplus. So maybe we haven't done the best we can do. And there's a hint here that if we were to try a different P2, lower than where P2 is, we could make B plus C bigger. In fact, if we made the price equal to the marginal cost, well, then we could just have no per unit profit and get all of our revenue from a membership fee. And in fact, that is the answer. Suppose we charge a price equal to the marginal cost. Then there's no per unit profit, but the hookup fee, or T, or the membership fee, becomes the whole area under the demand curve, which in terms of the labeling of regions on the last slide is all of them, A plus B plus C plus D plus E plus F. So the best we can do, if there's one consumer type, is to set a price equal to marginal cost and then to set a membership fee equal to the entire area under the demand curve above where marginal cost, above marginal cost. So this entire blue dotted region becomes the membership fee and becomes profit. Now, of course, there's just one consumer type. The world's not very interesting. When we add in a second consumer type, then we start to make use of sort of the full benefits of two-part tariffs. So the question is, what do we do if we have two types of consumers? To keep this kind of simple, let's just pretend there are equal numbers of two types. So it's sufficient just to say there are two consumers, one of whom has demand curve D1 and the other of whom has demand curve D2. And we're measuring again, along the axis, the number of whatever it is, each rounds of golf that they play in a year. Now, what are some things we might do? One possibility, based on what we learned in the previous slide, would be to set the price equal to marginal cost and set the membership fee equal to T. Now, what's T here? T is the biggest membership fee that we could choose such that they would both join. So it's the membership fee that's defined by the lower demand curve and the marginal cost curve. But is that the best we can do? Well, turns out it's not necessarily the best we can do. Let's think about a price that's above marginal cost, again with these two demand curves. So one possibility, again, is to have the price equal to marginal cost. And in that case, we'd have no per unit profits, but we'd have a profit from two membership fees, because both types would join. The membership fee would be A plus B plus C, and we'd get it twice, because, again, both would join. What if we had a price of P2? Well, with the price of P2 now, The highest membership fee that we can have such that both consumers join is just region A. But with a price of P2, consumer 2 would consume this many units based on where the price P2 crosses demand curve 2, and consumer 1 would consume this many units, Q1B. So as a result, we'd get some per unit profit. What would we get? Well, first of all, we'd get A 2 times, that's just the membership fee 2 times, and then from consumer 2, we would get B as per unit profit. That's the consumption out to here with this vertical profit per unit. And then we'd get B plus C plus D from consumer 1, this, and this. Now the reason B appears twice there and that A appears twice there is that really we have two diagrams, but they're just superimposed on top of each other. So we're not double counting. In one instance, we're counting B because that's the per unit profit from consumer 2's consumption. In the other case, when we count B plus C plus D, that's based on consumer 1's per unit profits. Now, to get back to the question at hand, are profits higher with P2 as opposed to P equal marginal cost? And the answer is that, well, yes, this latter piece is going to be bigger than the first piece if D is bigger than C. How do I see that? Well, the first piece is A plus B plus B plus C plus C. Again, that's the profit when P equals MC. What about the profit when P equals P2? Well, that's A plus B, but now C plus D. So if this D is bigger than this C, then profits are now bigger. Well, let's take a look at the diagram. Is D bigger than C? Well, yes, it surely is. How do we know that? Well, we can just look at it and see it, but we can also know it because D versus C come from this rectangle. You know, if we have a line through a rectangle starting here, if it comes through and hits below here, then this piece here, D, has to be bigger than this piece here, C. So that's a lot of words, but in the end, the answer is yes. We can do better with a price above marginal cost when we have these two consumer types. All right, let's do an example using a little bit of math. And from the last slide, we learned that in the terms of the labeling of regions on that slide, that the profit was equal to A plus B plus C plus D. Let's have some particular demand curves. Let's say that demand curve 1 is equal to 12 minus Q, P equals 12 minus Q. Demand curve 2 is P equals 10 minus Q. So again, this is a situation where there are two consumer types. We'll just summarize it as two consumers. In words, profit is per unit profit, which is always that vertical distance between the price and marginal cost, times the number of units purchased for each of the two types, plus 2 times the largest membership fee that gets the low type to join. In formula terms, then, that's this. So let's talk about that. This first piece, this is P minus MC. That's the per unit profit when MC is, well, the marginal cost is MC and the price is P. This is quantity, right? This is quantity on demand curve 1, because again, if P equals 12 minus Q, we can flip it around and Q equals 12 minus P, and that's what we've plugged in right here. This now is the per unit profit times the quantity consumed by the other consumer, consumer 2. And flipping that demand curve around, we get that Q equals 10 minus P. What's this last piece? Well, this last piece is 2 times the triangle that's above the price and below the lower demand curve. Now, if we have a particular value of MC, and one typically would be given a value of MC, and one would know it if we're working at the firm, this is an expression for profit as a function of the price we choose to charge. Let's work through that example with a picture. And here we'll use the demand curves we had in the previous slide, but now we'll say that MC, or marginal cost, equals 5. let's begin by thinking about the possibility of having price equal to marginal cost. We know that that's not necessarily going to give the best answer, but that's a nice benchmark for starting the discussion. Now, there are two possibilities for the membership fee. One possibility, the one we've usually been talking about, is to set the membership fee such that both consumers join. Well, of course, that's constrained by the lower consumer's willingness to pay, so we'll start with this one right here. So what's the area between this demand curve and this marginal cost curve? Well, this vertical distance here is 5, because it's 10 minus 5, and this horizontal distance here is also 5. So the area here is 25 over 2, just using the triangle formula, or 12.5. If we were to charge 12.5, we could get both of them to join, and profit would be 25. That would be all of profit, because there'd be no per unit price above marginal cost, so there'd be no per unit profits. One other possibility that I'll mention, but it's obviously not going to be the right answer, is how about if we had a membership fee that got only the high type to join, and how big could that be? Well, the triangle underneath the lavender demand curve and above marginal cost has a height of 7 and a base of 7. So that area is 49 over 2, or 24.5. We could charge 24.5. Only one of these individuals would join and profits would be 24.5. But we've already seen we could do better than that by getting them both to join with a membership fee of 12.5. But still, we're really working on the question, can we do even better than that? Now, to think about that, let's go ahead and use our expression for profit that we derived 2 slides ago. So here it is, and it's a little bit ugly, but with a little bit of algebra, plugging in, first of all, 5 for MC, and then doing a little bit of collecting of terms, we end up with this. Profit equals 12p minus p squared minus 10. And down below here, I've just illustrated profit on this axis, which we often call pi, and price on this axis. And you can see that, well, the profit rises as the price rises, and then the profit falls. But what's interesting is there is this region where profit has risen above the profit at a price of 5. 5 was kind of special. That was the price equal to marginal cost. But you see the profit's still rising, and for example, at a price of 6, you can see that profit's even higher. So to say it succinctly, the profit exceeds 25 at p equals 6, and yes, we can do better. Now, an alternative would be to use calculus. I don't expect you to necessarily have to do this. Many people find this straightforward or find this kind of natural, so I'll just mention it here. If you were to take that expression for profit that we had on the previous slide and take its derivative, d pi dp, set it equal to 0, you'd get that 12 minus 2p equals 0, and so indeed p star is equal to 6. When you plug 6 into the formula for profit, you end up calculating that profit equals 26. Now 26 is of course bigger than 25, so yes, we have found a pricing scheme, a two-part tariff, that beats just setting the price equal to marginal cost. We've shown how to put a two-part tariff into place, but what we haven't shown yet is whether we do better with the two-part tariff than we did without price discrimination at all. So in this slide, I want to talk about how this compares to what we would do if we didn't do price discrimination. Now, what we need to do in order to do that is, first of all, find the overall demand curve. Now, recall that the two demand curves here, for segment 1, or let's call it segment 1 or person 1, it was p equals 12 minus q. Of course, that can be rewritten as q1. Now we're going to subscript it because we're talking about person 1, equals 12 minus p. For person 2, the demand curve was p equals 10 minus q, so we can flip it around and say it's q2 equals 10 minus p. Horizontal summation here means, we want to have q1 plus q2 equals qt. When we do that here, we get that qt is 22 minus 2p. And strictly speaking, that's for prices 10 and below. If we flip that around, solve it for p, we get that the demand curve, the overall demand curve, is p equals 11 minus 0.5 times qt. The resulting marginal revenue is just bisecting demand, so marginal revenue is 11 minus QT. Setting MR equals MC, that's the way we maximize profit for a single price monopolist. That means setting 5, which is MC, equal to this expression for MR. And so when we solve it, we get that QT is 6 units. We get the price by going back to the demand curve. P equals 11 minus 0.5, in this case times 6, and that equals 8. And so finally profit equals, well, price times quantity, 8 times 6, minus the marginal cost times quantity, minus 5 times 6, and the answer is 18. Now remember, we got 26 when we used our optimal two-part tariff, so this is pretty different. Another comparison we can make is the two-part tariff versus third-degree price discrimination. Now, the way we do third-degree price discrimination is just by monopoly pricing in each of the two segments. Now I'm going to refer to those two individuals as segments just to use the language we used with third-degree price discrimination. But in any event, segment 1 had the demand curve P equals 12 minus Q, so the marginal revenue curve for that segment is 12 minus 2Q. If we set MC equal to MR in that segment, that means setting 12 minus 2Q to 5. So the quantity is 3.5 or 7 halves, and the associated price, which we can get off of the demand curve, is 8.5. And again, that's 12 minus 7 halves, 8.5. Before we calculate profits, let's just go over to segment 2 and find the optimal price and quantity. Excuse me. And there we get that the demand curve is 10 minus Q, so MR is 10 minus 2Q. Setting MC equal to MR means setting 10 minus 2Q equal to 5. And so the resulting quantity in segment 2, and I suppose I could put a 2 there and a 1 there, is 5 halves, and the price in segment 2 is 7.5. So profit then equals 8.5, which is the price in segment 1, times 7 halves, which is the quantity in segment 1, plus 7.5, which is the price in segment 2, times 5 halves, which is the quantity in segment 2, and then minus 5, which is the MC, times the total quantity. And 6 just happens to be, well, it doesn't happen to be, but 6 equals 7 halves plus 5 halves, the total quantity. We solve that out, we get 18.5. Now 18.5 is bigger than 18, but again, the two-part tariff, which in its best form delivered us 26, does a lot better. And it's interesting to note that even the crude two-part tariff, the one that had P equal to MC, that one delivered 25. So these two-part tariffs really are very powerful. All right, what do we learn from this section? Well, first of all, two-part tariffs can raise profit without treating consumers differently. Again, think back to first-degree price discrimination. We're going to take each person and offer him or her a different price. Here, at the end of the day, we've found a hookup fee and a per-unit price, and that schedule is presented to everyone. Everyone gets that same schedule, but they make different choices about how much to consume, and so in effect they pay differently, but they pay differently because they consume differently. And so we would call this a self-selecting as opposed to a discriminatory pricing scheme. Second point, they're important for some firms. I mean, just think back to that quick discussion of Costco. Huge part of their net income has to do with their membership fee. How do we go about solving these problems? Well, we've got to typically make a diagram, write out an expression for the profit as a function of the price, and then see how that expression for profit evolves as we try prices that are above marginal cost. That's kind of a rough guide to solving these problems, and it tends to work pretty well for this course.